So in this video, I'm going to show you how we can take a sub-D geometry like I've created over here and reference it into Grasshopper. And this particular script is going to panelize it in a way that it creates a tessellated space frame with integrated quad paneled glazing. And we're going to be able to isolate each of these different parts and bake them out like so. And once you begin to bake them out and colorize them, you'll end up with some geometry that looks like this, where we've got our exterior quad panels, and then we've got this interior space frame, as well as these particular spider joints that run and connect to the space frame over here. I've also broken the glass down into two different objects. So we've got the exterior glass panels like these, and then we've got a secondary layer that have all of these interior panels to them. And the reason that I've done this is so that we can actually render this out a lot more photorealistically.
Even if you've never used Grasshopper before, you should be able to apply these scripts really easily. But if you do want to feel more comfortable in either Rhino or Grasshopper, then I have full, completely free tutorials on both. I'll link them in the description below. They're both really good, extremely comprehensive, so you can learn really everything that there is to know over the course of a couple of hours if you apply yourself. And as I said, they're totally for free. These free resources are supported by our product range of artist pencil cases, which I've personally designed, manufactured, and actually assemble myself. They come in 3 sizes and a range of colors, and each one is unlocked using this incredibly intricate mechanical system, which is just insanely satisfying to use. To be honest, everything at Legacy is actually done by me at the moment, from researching course workflows to website design, to video editing, to printing parts for products, to making the packaging, even building this whole office. And I do this while juggling 2 semi-full-time other jobs. So if you decide to pick one up, I would be hugely grateful and really excited to share one with you, because not only would it contribute to great industry resources like what you're watching at the moment, but also the journey of Legacy Design Studio as an innovative organization within the industry. They also make really impressive and thoughtful presents for basically any occasion and for anyone with any interest in design or creativity whatsoever. So please keep them in mind in the future. Now onto this tutorial. This video is a free resource that will walk you through the whole fundamental Grasshopper workflow so that you can begin to design things like this by yourself. But if you want to download the script, you'll need to head to my website, which I'll link through the description below. I hope you appreciate that I've tried to make this as accessible as possible, and I am trying to balance this against the substantial time and monetary costs involved in producing resources of this quality. You can download the script either on a monthly plan or get lifetime access. And interestingly, lifetime access has actually been far more popular, probably because it means that at any point late at night or under the pressure of a deadline, you can jump in, grab a script, and immediately show your tutors that you've been actively developing fabrication strategies. It's a real lifesaver when you need to produce a lot of work very quickly. And because I'm constantly adding new content, lifetime access also means that you'll be getting a growing library of resources well into the future. Alongside this script, there's a huge range of other designs you can apply as well. I know it almost feels like cheating design school because you can produce a lot very quickly, but honestly, it's the easiest and most rewarding way to learn Grasshopper. What's even more impressive is that there is also a large range of extremely advanced scripts for fabrication that allow you to reference in any geometry, and it will automatically produce fabrication files nested onto sheets, ready to be either printed or laser cut with panel numbers and connection guides. There's even inbuilt fabrication guides in the scripts themselves, and of course a detailed tutorial video for each one. Your tutors would find this insanely impressive because there are very few people in industry that possess these skills, and these scripting resources make it more accessible than it's ever been to actually produce this work. So next time that you want to learn some industry-leading workflows or have a deadline coming up that you want to generate some very impressive work for, keep these resources in mind. Now let's get on to this tutorial.
As you can see, this is our tessellated space frame integrated into quad paneling script. And I'm going to break this video down into 2 parts. So firstly, we'll go through a quick overview of what each part of this script does, and then I'll show you how you can actually reference and panelize your own designs and play around with the settings so that you can create your own designs from this script. You'll notice as well that each part of this script is really cleanly organized and well labeled with explanations of what each part does. I've done this for 2 reasons. Firstly, I've done it so that it's as straightforward as possible for you to actually use them, but also so that you can actually look over this script and learn from these scripting techniques and the components that I use, and then you can actually apply this to your own scripting as well. So to get started with this script, let's zoom into this initial part over here. And what I want you to do is I want you to select this initial geometry, and we're just going to zoom out so that we can actually see this space frame. You can either do this manually inside of Rhino, but what I suggest doing is clicking on the canvas. Make sure that you don't click on a group, click on an empty bit of canvas, and then you can say zoom, and it's going to zoom directly into this geometry over here. Now, if we zoom out of this script, you'll see that there are 4 different parts to it. So we panelize the shape, we create the glass panes, we create the space frame and ball joints, and then we create what's referred to as the spider glass fittings. And that's basically how we connect the space frame onto the actual glass piece itself in detail over here like this. So to show you what each part of these things do, just quickly, we're going to select this green icon so that we only preview what we've actually got selected. So we start off with a base sub D shape like this. This yellow part of the script actually panelizes it, so each one of these panels will be a glass pane itself. Then the first part of the script actually creates these pieces of glass, like so, and it does it in 2 parts. So first of all, these are our glass panels, but to render glass really effectively, you need to differentiate between these glass panels like this, and then the edges of these panels as well, because they'll be different materials. This will be a much darker color of glass. So we've got our glass panels, and then we've got our glass edges over here. In the next part of the script, we take all of these panels and we actually generate out the space frame from these panels like this, and also the ball joints, so you can see up here. And then finally we take all of the space frame and the panels, and then we create a connection between them, and that's called the spider glass fitting. And so that looks like this. You can see the connection between the panels and the space frame itself. In the final part of the script, we've got the options to bake each of these parts out individually. You can see that you can isolate the ball joints, or the space frame, or the glass panel, the glass edges, or the spider joint, and you can bake these parts out individually onto different layers so that you can render them in different materials. Finally, over here, you've got all of your preview settings. So if we click this green icon up the top right, we can change how these are previewed. So you could change the color of the glass to be more green, for example, or you could change the color of the space frame to be, I don't know, red or gold if you wanted to. Whatever you want it to be. Now, in the next part of the script, we're going to go back to the initial part here, and I'll take you through how you can set your own geometry and play around with the different settings in this script so that you can optimize it for however you want this to be displayed. So the first part here is, if we go to step 1, that we can set our own geometry. So if I turn the preview settings off, you can see that you can set any sub D that you want to into this. Just keep in mind, try to set a sub D of roughly the same size, and this will hopefully avoid any potential script complications, and it'll roughly generate out a similar number of panels as well. So you just select your geometry and you right click on this component and say set 1 geometry. Now after this, it goes through and it will actually panelize this shape. So you've got this option up the top here, and this is the number of panel multiplier. So you can see that the panels are roughly like this size and shape. If we were to set this to 3, then there's going to be much more panels in this actual shape. It might take a while for this to actually compute out, and see how this is much denser than when we had our original value of 1. So I'm going to change this back to 1, and you'll see that all of the panels are much larger, and there's far fewer of them. It'll say here how many panels you've actually got. The next part here is that sometimes the panels are facing the wrong direction, so you can plug in this flip mesh into the panel faces like this, and you'll see that the space frame will be generated on the other side. Whereas if we plug it in directly like this, then it flips it around. Now you've got the settings here for all of your glass panes. So let's start off with this value here is the glass offset amount. So if we were to set this to 400, you'll see that the glass panels end up being far further offset, like this. Then you've got the thickness of the glass panes. So this is the thickness of the glass. If you were to set this to 100, it's going to be much thicker. So even like 30 mil glass is relatively, well, that's probably the size that it would be created in real life. After this, you've got your space frame settings. So this is first of all the space frame depth. If we were to change this to 1000, it's going to be go much deeper in. If we were to set this to 200, it's going to be much narrower like that. It's very fast to actually compute through this script. After this, we've got the ball joint radius. So this is the size of these ball joints here. If we made them much smaller, they'd be tiny or much larger. You can make them much larger like that. Over here, you've got the space frame thickness. So at the moment, it's 20 millimeters, but we can make that much thicker, like 50 millimeters, or much thinner, like 10 millimeters, if you wanted to. 20 seemed to be the sweet spot for this script. And then finally, you've got the spider glass fitting, which I might highlight over here in red so that you can see it a bit better. You can see that the edges are previewed out in red. And so for this spider glass fitting, we can change the fastener position on the panel. So see at the moment how it's offset inwards like this. See how it's offset inwards? We could have it offset further if we had it set to 0.6. Or we could have it offset more towards the edge if we had it set to 0.9. But 0.8 seems to be the sweet spot for all of these panels. We can change the fastener radius. So instead of 20 millimeters, we could have it much, much thicker at 100 millimeters like this. And you'll see that it becomes much, much thicker. And then you can change the fastener offset from the panel. So this will actually change how far this fastener offsets from here. So if we had it set to like 10, then it will potentially be inside the glass. If we had it set to 100, it'll be much further off. Finally, over here, we've got the connection, the spider connection thickness. So if we had this set to 30, this will end up being much larger as well. So you can set all of these different values around if you want to. And then finally, you can just go through and you can bake each of these individually into whatever layers that you want to and represent them in whatever way that you actually want to. And this is how you can use this space frame script in a very easy way.